Hello students, in this video we are going to learn about defuzzification. Already we have seen what is meant by fuzzification, converting the crisp value to the fuzzified or fuzzy set is called as fuzzification, and converting the process of converting the fuzzified output into a single crisp value is called defuzzification. Okay, just I'll give the representation. If you see here, so we'll take the crisp values, we are converting into the fuzzy set, and this is called as fuzzification. If I take the fuzzy value and convert into crisp value, this is called as defuzzification. Only thing we have to remember here is only one crisp value is generated out of the complete fuzzy set. So just I'm telling conversion of fuzzy set to the crisp value is called as defuzzification. Done? Yeah. Now we'll start. So what are the different kinds of methods available for defuzzification? First one is center of sums method, center of gravity or center of area you can call it. Next one is center of area, bisector area method, weighted average. Then maxima methods. In the maxima methods, we have first of maxima, last of maxima, and mean of maxima. Now we are going to do problems in this all methods. Starting with the center of sum method. So don't worry about the formula, just I'll explain what is that, then we'll check the expression. Now all of you see here, so this is an example where if you see here, just 1 second, yeah. So what we are doing, so if you, what you understood from the diagram, what we can understand, okay. So here, these are the x values in your fuzzy set if I write, okay, x1 comma 0.2. So just this is an example, okay. So the x1 is 1. So what is the fuzzy degree of membership of 1? 0.5. Got it? So here, if I take 2 is your x2. What is the membership value for that? If you see the graph, it is around 0.4. Just I'm telling 0.4. So similarly, these are your x values, okay. And when you check out this, these are your membership values. Like that, when I graph or when I map all the x and y, I'm getting this graph. Done. So what I have done, see, generally the graph will be like this. I'm dividing into some areas for my calculation part. Now I have here two areas, A1 and A2. Now I have to calculate the areas A1 and A2, and I also have to calculate the x1 bar and x2 bar. These are called as center. Okay, center values we have to calculate. Then the formula will be A1 into x1 bar plus A2 into x2 bar. A1 is the center value for, sorry, x1 bar is the center value for A1, x2 value is the center value for A2. Then finally I'll take A1 plus A2. So this particular value is called defuzzified value for this particular fuzzy set. Now how we have calculated, just we'll see here. Now, if you see this formula, A1 equal to half into 8 minus 1 plus 7 minus 3 into 0.5. So hold here, I'll show you how we got these values. Now, if I take the area of A1, okay, so here if you see the last line, it is 8. So 8 minus 1, got it? And if you see these particular two lines, it is 7 minus 3. So I'm calculating this particular area and this particular area, that is 7 minus 3 into, what is this top value? Closed value is 0.5. Got it? So once again, I'll go back. Yeah. So half into 8 minus 1 plus 7 minus 3 into what is a y value? 0.5. So when I calculate, I'll get 2.75. So this calculation we can look at, no problem. Now if you check the A2 value, see. So what is A2? End here it is 9. 9 minus 3. And if you take this line, 8 minus 4. So what will be the value? Half into 9 minus 3 and 8 minus 4. And what is the top value? Y value is 0.3. So we are right. Just we'll check it out. Yeah. So half into 9 minus 3 plus 8 minus 4 into 0.3. So this way we will calculate A1 and A2. Now how to calculate the center of area value? So if I show here directly, if you take this particular rectangle box, the center of this particular will be 7 plus 3 divided by 2. That's it. And if you take this particular A2 box, 8 minus 4 divided by 2. Okay, so I'm just going for the equation. Hope we have done. Yes. So C1 is 7 plus 3 by 2 and 8 plus 4 by 2. I'm getting 5 and 6. Okay. Now we got the complete values. If you see the formula here, x equal to whatever variable you can put it. So the defuzzified value is summation of I equal to 1 to k ai into center value of xi. Similarly, summation of I equal to 1 to k ai. So here I have only two areas. If you have three more areas, you have to add A3 also. So that depends upon your fuzzy set and how you are going to mapping that particular fuzzy set. Done. Now, if I substitute here, all of you see here, A1 into X1. So A1 is your 0.275, yes, into what was my center of area of this particular C1, whatever it may be. So it is 5 plus, here it is 1.5 into 6 divided by A1 plus A2. What is my A1? 2.75 plus 1.5. So I'm getting 5.35. Okay. So just I'll brief in two lines. So what we are doing in center of sum method, first I'll calculate the A1 and A2 values. Then I'll calculate C1 and C2 values with the help of center of area formula. Then what I'm doing A1 into x1 bar, A2 into x2 bar divided by A1 plus A2. So I'll get the center of sums method using this particular process. So the defuzzified value of this complete fuzzy set is 5.35. Okay. Now, coming to the center of gravity method. So this method, what we are going to do, the area and the center of gravity or centroid of each subarea is calculated and then we are using the summation. So how we'll do this? We'll see with an example. So we'll take the same example. If you see the same figure, not a problem. Now what we are going to do? So again, don't worry about the formula. We'll see the problem here directly. Now, here the interesting point is that you have to calculate the area of each and every part. If I take this is one part, again this is one part, again this is one part, again this is one part. So that's why here we are not mentioning A1 and A2. I'm taking identifying the parts. So this is 1 and this is 2. Why I'm not covering this? Because in the 2 it is already covered. So this is not covered. So 3, 4, 5, 6. So please, I'm repeating once again. Now 1 is there. So this is a triangle. I'll apply the formula for that particular triangle and I'll calculate. So this is the square of rectangle according to that. I don't put here this particular triangle because this area is already covered by 2. Done. Then I'm taking this small part which is not covered earlier. 3, 4, 5, 6. Now, how I am calculating here? Total area of subarea of 1, half into 2 into 0.5. So if you take, it is triangle. So half, what is half here? 0.5 into, so total this is 2 and this is 1. Clear? So half into 2 into 0.5. Why 2? Here it is only 2 points. Okay. So half into 2 into this one. Height is 0.5. So this is your first part. Similarly, if I take second area, 7 minus 3 into 0.5. So total it is 7 minus 3 and your x value is 0.5. So this is done. If you take the third part also, half into 7.5 minus 7. Why I got here 7.5 minus 7? Because we already calculated here. See here. Oh, 1 second. So this is already according to this particular graph, 7.5 minus 7. So if you see here, it is in between 7 and 8. So I'm taking 7.5 minus 7. Done. 7.5 minus 7. So similarly, we'll calculate for 4, we'll calculate for 5, we'll calculate for 6. Now, these are the sub areas of 1 to 6. Now, we have to calculate the centroid. So how to calculate the centroid? So centroid for formula for centroid is sub area of 1 is 1 plus 3 plus 3 by 3. So if you take the first one, okay. So if you take the first part, the centroid will be according to the formula. So how to calculate the centroid of this particular triangle or whatever area if you take. So accordingly, we'll put here 1 plus 3 plus 3 by 3. And next one is 7 plus 3 by 2. Then 7 plus 7 plus 7.5 by 3. So like that, we will calculate all the centroid values. So centroid of 2 is 7 plus 1 second, 7 plus 3 by 2. So if I take the second value, so if you take this centroid value will be 7 plus 3 by 2 divided by 2. Yeah. So total it is 2. Okay. So like this we'll calculate the centroid of each area. So what we have done, we have summarized over here. So I've calculated area, I've calculated centroid for every part. Then what is my formula? I have to calculate AI into centroid. So area into your centroid value. Finally, I'll summate everything. So I'll do 0.5 into 2.3, that is 1.16, 0.2. 5 2, sorry, it is 2 into 5 10, like that we have calculated everything. Now what I'll do here, so I equal to 1 to n AI into xi, total AI. So these are all AI, so total will be down, and now I have to total this one, 1.161 plus 10 plus 0.3, 1.0, 1.1, 1.2. So finally I'll get 5.008. So this is the center of gravity method. So what we have done in center of gravity, first I'll split into different areas. I'll calculate all the areas, then I'll calculate the centroid, then I'll multiply and then do the summation. And finally, I'll find out like using this particular formula. So this is a second type of method. Now, third one is center of area method. It is also called as bisector method. So it is very interesting. I'll show you with the diagram, then you can easily understand. Don't worry about this formula. Now, what we have done in this example, and see, these are the values. Example means 60, for 60 it is 0.6, 70 is 0.4, 80 it is around 0.2, 90 is 0.2, 100 it is 0. So what we are doing, first I am bisecting the values. Okay, if you see the formula, so it is very simple now. So 60 into 0.6, if you see here 60, so what is the value here? 0.6. Previously we took the x values, now we are taking the bisector values. Okay, if you observe, these are bisector values. 70 into 0.4, 80 into 0.2, 90 into 0.2, 100 into 0. So that will be the formula. So 60 into 0.6, 70 into 0.4, 80 into 0.2, 90 into 0.2, like that. Finally, down what you are adding, only these values, 0.6 plus 0.4 plus 0.2. So this particular defuzzified value is 1.4. Okay. Now, coming to the last part, we have three methods: first of maxima, last of maxima, mean of maxima. These are very, very simple. In the first of maxima, I'll check what is the first maximum value. So 4. Got it? For 2, it is actually 2. If you see the 2, it is not. It is little biased. For 4, it is the maximum value. So what is the maximum value over here? 0.4. So this will be the solution for this. Second one is last of maxima. If I take the last of maxima, so what was the last value for the maxima I have to take? So maxima, see, don't, it will be last of the maxima is 0.8. I'm not telling last value. Remember this statement. So last of maxima. Okay. So last of maxima is 8. And third one is mean of maxima. What is the mean of maxima? You have to take the first and last, and finally you have to calculate the mean. So if I take here, first of maxima is 4, last of maxima is 8, we have to calculate the mean of this particular 4 and 8. So this completes our defuzzification methods. Okay, so just you practice so that you will get more examples and you can easily capture. Done. Thank you.